Good morning, ladies and gentlemen. How y'all doing? My name is John Belkwitz. I am the president and CEO of EDYSTON, and I'm here to give you an awesome presentation on what we like to call the magical world of concrete. Now, a little bit more specifically, I'd like to give you some information on the EDYSTON products that we've been using over here in the cruise tunnel and about to do some bridge work and uh, concrete rejuvenation. And ultimately, this is all focusing on laboratory and field evaluations that we're conducting with you and your crew. And before I get into the meat of the presentation, I'd like to give you a quick overview of what we're going to be talking about today. First and foremost, I wanted to give you our project purpose and highlight the three top tiered items. After that, I'd like to go into the how to and where to use the different EDYSTON products. We have three different products, and we've got a really easy way of identifying which are the best for your concrete or deteriorated concrete, like we have here in the photo, or maybe not as bad. After that, we're going to go into the methods that we test and prove the efficacy of the EDYSTON. And after that, I'd like to show you some of the results from our testing that, again, proves the efficacy of this technology and how it rejuvenates deteriorated concrete. And then finally, I want to summarize this and show you the next steps, where we're going here in the future, and then open up the floor for any questions. All right, so let's dive into this. So ultimately, the project purpose here is a proof of concept. The EDYSTON has shown a lot of successes throughout the years in the laboratory. We've done some mock-ups, but this was really the first foray, the first journey into the field. And ultimately, what we're doing is working on a solution to the largest concrete problem that's plaguing our construction industry. And while there's a manifold of issues out there with concrete, the biggest one is we have, $8.3 billion a year price tag that goes into the maintenance associated with concrete physical and chemical attack. Now, I'm not saying concrete's broken, but at an $8.3 billion a year price tag, we definitely need to fix it. I mean, we have over 600,000 concrete bridges in our national inventory. Not all of them look like this, but there's a large majority where you can definitely see the steel reinforcement. Concrete's done scaled off, or it's scaling, or it's flaking off, coming off in sheets. In this proof of concept, we wanted to measure the impact and capacity of the EDYSTON hydrogel technology to rejuvenate cracked concrete. Now, the significance of this phenomenon was elucidated by employment and deployment of a modified version of ASTM 1585, which is the concrete water sorptivity test, or as most of us have called it, the concrete wicking test. And I believe this is a test that was made popular by the Ohio DOT. I keep saying that's something I need to look up again. And it's important for us to have a way to measure this. What we're dealing with is something that people have shied away from, put band-aids over, because there's never been a really good solution for dealing with concrete that is going through the deterioration cycles. But that's the purpose of our chat today. So, I wanted to go into the how-to first because it's a very easy application, and I compare it to treating a wound. And I've got 4 kids, ages 2 through 11. And oh gosh, I think we have stock in Band-Aid. Anyway, we have a lot of Band-Aids in the house because somebody's always bumping and bruising and skinning a knee up. And I'm sure there's a few parents, nephew, or uncles, aunts, godfathers, godmothers. Most of us get to hang out with kids, and or just on our own time, when you get scraped up and you got a wound, especially if it's a little bit older, um, before we put the band aid on the wound, there's some treatment. And in a similar manner, we're going to treat the concrete like we would treat a wound. So, when working with the Eddystone, you're going to use the Eddystone as if it's an antiseptic, as if it's an antibiotic, probably is a better way of saying it, on the concrete. And the first thing that we want to do to that deteriorated concrete is we want to power wash it. And you're power washing it with a standard 3,000 to 3,500 psi pressure washer to remove salt and weaken concrete. Now, what this also allows you to do is get the concrete in its preparation state, which is a saturated surface dry condition. And what that means is, for those of you who have never done that before, it's a condition where the concrete has absorbed enough water that the surface doesn't have that gloss, that sheen. There's no water dripping off of it. It has actually dried, and every time you spray it, it stays in that, with water, it stays in that dried state, but it's not going to absorb an excessive amount because you've already saturated that subsurface in what would be called the body of the concrete. And of course, what we're talking about here is deteriorated concrete. And I want to be very explicit about that. This was never designed for new concrete. And as it turns out, the more deteriorated and cracked up your concrete is, the more paths to the body, the more paths, body of the concrete, more paths to reinforcement. And that's part of the mechanical interaction that we see between the Eddystone and the deteriorated concrete. So we've got our concrete washed, removed the salt and weakened concrete. We have it in a saturated surface dry condition. If this is something that you've come back to the next day, then you've got to go ahead and apply or get more water on it to that SSD state. But then once you're there, you're applying the Eddystone at 125 square feet per gallon max, or as much as the concrete will absorb. And you're going to be doing this in successive passes. You're not trying to inundate the concrete all in one shot with this 125. You don't want excessive dripping, or as my carpentry teacher taught me back in junior high school, you don't want holidays. You definitely want to have a universal coating of that sprayed Eddystone. Now, when we talk about Eddystone, there are three products that are used to treat concrete. And when we see that our concrete under review has light cracking with minimal gels and salt leaching from the cracks, the cracks can be located in full construction joints, columns, walls. Here it's a pavement, sidewalks, and more. This is an awesome skate park in Idaho, right outside of Shelley, that we've got an excessive amount of cracking, but you can see there's no real steel bleeding out of it. There's no salt leaching or excessive salt leaching. And the same thing for this sidewalk here. We haven't seen the deterioration mechanisms really take off yet, but there is obvious signs of cracking. And this is when we're going to use our baseline product. And this is a product that's going to be used throughout. This is our Densy gel. And this is used on all concrete where we're starting to see that cracking, whether it's light cracking or excessive cracking here, but before we see the salts and the bleeding of the steel. Now, when it comes to the EnviroGel, this is when we're going to use, or we're going to use this when we see moderate to excessive concrete cracking that leads to salt and rust leaching from the cracks, the full construction joints, and so on. And to a certain degree, we can also see some of that salt leaching out, and maybe you don't see it in this picture. Excuse me. But in this one right here, and I believe this is a video, I'm not going to show this video today, but it's one of my favorites. This is from Denver International Airport. This is columns in their parking garages, and I mean really just all over the place, where they have this ASR attack that it's prevalent. I know y'all don't have that issue here, but it's prevalent in Colorado, and we see that Isle of Man cracking. We see that gel starting to leach, and when the gel dries, you can see that salt. So this is where we'd use a combination of that EnviroGel and that Density Gel. And what we would do first is apply our EnviroGel at 250 square feet per gallon, and then come back with the Density Gel at 250 square feet per gallon.
Look at that.
Okay, sorry. I really love that deterioration. So the EnviroGel here is also could be used on decracking for our concrete pavements, and just like the failed concrete structure, you can start sealing the salts that have migrated in and are now starting to leach out, as free chlorides often do. There's a wonderful paper written by Doug Hooton, or our Doug Hooton, on the transport of free chlorides from concrete. And then we get to our Duragel, and you're using the Duragel when the concrete has really its last legs of life here. When excessive concrete cracking leads to significant salt leaching, rusting, and deterioration. This is where the concrete and the steel are showing their signs of that final deterioration mechanism here. We got veins of salt bleeding through, as well as the rust and the breakdown of the steel. And you can see that rust has created a delamination effect from the concrete cover and has caused some of the concrete to break away. So before we put our patch on, we're going to be cleaning the concrete, per that discussion that we just had, and then we'll be applying our Duragel at 100 or 250 square feet per gallon, and then our Density Gel. And it's not just in our concrete tunnels where there's an excessive amount of steel. We also have the opportunity to take advantage of the Density Gel on sidewalks and pavements. And this sidewalk is really important to us as sidewalks go. I'm a big fan of sidewalks. But this sidewalk in particular, this is at Whitney's grandmother's reminiscence home, and she just passed away not but a couple weeks ago, God rest her soul. But we went out there to visit Grandma Bitter a lot. Basically raised Whitney, and our girls were just smitten with her. She's one of the most awesome ladies out there, and we used to take a lot of walks with her and the kids around that reminiscent community, and it really was a beautiful community. They take care of it very, very well. It's outside of a potato farming community. So in going there, I mean this is what I see on my walk around the community, and the concrete out there is just, oh, that poor concrete. It's just falling apart. So we went out there on 21st of June 2019, exactly, 3 years to the date. Later, I took another picture of that concrete sidewalk, and you can actually match up the cracks on the right-hand side to prove that these are the exact same pieces of sidewalk. But as you can see, in a short period, and yes, I would call 3 years a very short period, that one little scaled or flaked off area in the bottom left-hand corner of that joint turned into this totally broken down area from the wheel path of the wheelchairs, the walkers, folks walking. And the reason why the concrete is going through such a deterioration cycle is, the de-icing salts and brines that they use, the wetting and drying cycles from their irrigation system. It's absolutely beautiful with the flowers and trees there. But also the freezing and thawing cycles, and of course the abrasive wear from foot and hard-wheeled traffic. The EDYSTON, the combination of the Duragel and the Density Gel could have been used on June 2019 to halt some of the deterioration. And in another way, EDYSTON is similar to Rogaine, where Rogaine was designed to stop the hair loss process. Here, EDYSTON is used in a similar manner, not only to rejuvenate and give that concrete new life, but it's really to stop that deterioration process, halt it in its tracks, so that the maintenance manager, the facility owner, can make a more intelligent decision uh, to mitigate this. And I mean, at this point, this concrete has to be either patched or replaced. We can't just spray Eddystone on it, especially when it comes to slipping and tripping hazards. We've got some issues here with our matured community. Okay, next slide. Our methods. Oh, I love this. So this is when we get to talk bookcrete and labcrete, and the method that we're using is a modified version of ASTMC 1585. And if you haven't read it, it's a wonderful ASTM. The group that put it together did a great job. The reason why I like this test is this shows a little bit more than the concrete's ability to absorb water in a 24-hour period like ASTMC 642 does. This test shows us a primary and secondary absorption that all leads back to the concrete's ability for water sorptivity over time. And basically, the way we're doing is we're taking a whole bunch of samples here. Let's say we have 10 samples. Focus in on one of those samples that we're going to cut into thirds. And with that sample, what we want to do is the samples, we want to create a manufactured crack. So we're going to actually cut that 2-inch tall, 4-inch diameter, 3-inch diameter, 6-inch diameter puck right down the middle to create that manufactured crack with a saw cut. Then what we're going to be doing is we're going to be epoxying everything around that concrete sample minus the bottom surface. Now we're doing that for two reasons. One, to bring that crack together so we have a hairline crack, a 1/32 of an inch crack. And the other reason is per the ASTMC 1585, where we want to just test that one bottom surface that's going to be touching the water, as you'll see here in a minute. And with all tests, we're going to make a representative set of samples so that we can have duplicates or triplicates and test these over time. And when we look, as well as the reference, as well as the different EDYSTON products that we're going to be putting on there, and the way the sample works is after we get our crete or our concrete that's not being tested, treated and coated, and it's secured, then we are going to acclimate our sample in a closed environment for 2 weeks. After that 2-week period, we include a 3 millimeter bath of water, 3 millimeter high bath of water in the sample, and we test it over a 7-day period. Now, the first day is probably the most exhaustive day with testing, where you're testing it, I think, 1 second, 2 second, it goes in these multiples until you get to about 6 hours, and then you start going a little bit longer intervals. And what we've done here is we've set up an example with standard concrete where we have a control concrete with no cracks to it. Then we have, and that's in orange, we have a concrete sample with fatigue cracks in it. And that's taking our concrete sample, instead of cutting it right down the middle to create that manufactured 1/32 of an inch crack, we're applying a load that would cause catastrophic failure, 40% of that load, on a cycle of 10 times to create those microscopic cracks. And then, of course, finally, we have that manufactured crack at 1/32 of an inch. And as you can see, the fatigue cracks, we're not getting as high as a primary or secondary absorption. It's actually similar to the control. And we attribute this to we're exposing some hydration kinetics. We're not creating true cracks. We're creating percolation that over time will densify and absorb water for the benefit of the concrete, as opposed to the full crack where we're actually absorbing enough water that we have a almost like a super absorption, or a storage of water that is not being used for absorption of broken particles or fractured particles, as well as cement hydration. All right. So again, this was showed as an example with standard concrete in these photos, or in this image, this data set. We haven't applied the EDYSTON, but let's get into that. The results. So what we did is set up a series of tests um, using this ASTMC 1585, and we pre-treated the concrete crack first with water, or potable water, um, and we applied the Density gel at 125 square feet per gallon, and then ran the test 12 hours later. And of course, we had our references, and with the reference, we went after the same standard operating procedure that we were going to use with in the field, as well as on this other Density gel sample. We wanted to keep all the samples have the standard method, or the same method. And what we found after 7 days is that the Density gel bridged that concrete crack, rejuvenated it so that it absorbed less water than the reference, or the concrete crack without the Density gel. We reran, or ran with another set of samples using the Duragel, or the Duragel, but in lieu of using just potable water, we used a sodium chloride solution in 8% solids. And the reason why we did that is oftentimes when we go out to the field and we see concrete cracks, those concrete cracks aren't clean and free of chlorides or sulfates. They're actually pretty much inundated, as we see in our cruise tunnel job site, with a significant amount of salt. And as you'll see here in the next a couple of weeks, or excuse me, the next few days, we'll be sending out our technical data sheets. We also ran these tests using simulated cement pore solutions, and saw a similar effect where the reference was actually drawing in water. And that's what those salts do, is they have a capacity to imbibe water. But the Duragel, even though there is a certain drawing in of water to create the hydrogel, we are creating that bridging of the concrete cracks that reduces the tendency for that concrete crack to imbibe water. So what does this all mean? Why do we care? To summarize this, we're running these tests as a proof of concept to show how efficient the EDYSTON products are at rejuvenating, bringing, or giving that concrete a new life. And what we've seen is a plus 40% reduction in water sorptivity when using the Density gel and the Duragel. And we've seen the same thing when we're, instead of using the sodium chloride or just the water, we're using a simulated cement pore solution on the concrete cracks in a similar manner that we would see in our job sites. Where we're at right now is the last time we gave you this presentation, we were planning to grab some cores. We're actually asking for permission, and thank you for that permission. Really appreciate the support from Keith and Dan and the local Fort Wayne community to help us get these. We had a great time working with your concrete coring companies, as well as your rebar locating folks. So these cores are out here in New Jersey, and we're going to be getting them out to Michigan here soon. We're running a set, and then we're going to have Larry Sutter and his team running a set too. We've already started putting our sample sets together out here, and I'm just getting confirmation on Larry from a shipping address. And bear in mind, this was all from the cruise tunnel. Keith and I had a great conversation a couple of weeks ago, and Keith, thanks for your patience and your resilience. This move to New Jersey with the kids and the dog and the lab has been a little bit more time consuming than Whitney and I originally thought. But we're going to be going back to the tunnel, sweeping it out and taking a measurement and the amount of waste that's breaking through. And this is a testament to what we said that the EDYSTON is designed to do, which is halt that deterioration process. And just like the ASTMC 672, what we're going to be doing is every month measuring the amount of waste that is falling on the non-treated side, on the left-hand side over here that we see in the picture, versus the EDYSTON treated side on the right. And for those of you who weren't on the screen, where are we? We are measuring the impact and capacity of the Eddystone hydrogel technology to rejuvenate cracked concrete. And this is directly from the field. We've already completed the simulate cement pour solution pre-soaks 1 and 2. You already have data from round 1, and now you're going to see data from round 2. Excuse me. You're going to be getting both data round 1 and 2, and then we are in progress from the cruise tunnel cores, and that's both Intelligent Concrete and Sutter Engineering. Want to thank you for your time and your patience, and open up the floor for any questions. Bear in mind, obviously, this is a recorded event, but please email me your questions. Don't hesitate to reach out. And I say that because we've got a lot of deteriorated concrete that we need to deal with. The concrete photoed here, or in the photo here, is not photoshopped or filtered. This is real concrete on real U.S. infrastructure that is currently being used to maintain the day-to-day operations of this great nation. Now, eventually, this concrete structure is going to fail, and we're going to have to replace it in a hurry, and that's normally expensive. Eddystone gives us the ability to increase the resiliency, the service life of concrete structures, so we can make a more timed decision, use our taxpayer dollars more efficiently, and create a concrete that is stronger and lasts longer. And the last thing I'd like to do is, before we close this job site, what we did is we split that 400-foot long tunnel down the middle with our 7 full construction joints, and in this area we show you a picture of what the hydrogels look like. And this is I believe it's like 2 or 3 minutes after we combined the Eddystone with a simulated cement pour solution, and you can see how the gel, these are 2 liquids that were formed together, and you can see how this hydrogel is starting to form a rigid structure, and this is what it's doing in the concrete that's going to hold its shape. That it's got not only a 3-dimensional structure at the micro level, but at the macroscopic level, it has already started to create that structure that could bear strength. So thanks again for your time. Excited to hear your questions. Go concrete, beat asphalt. We cleaned the entire joint, the upper portion of it, and then we treated the left-hand side in this portion, the black side, and left the right-hand side, the pink portion, untreated, and came back and cored both sides of the joints, and and 2 on either side of the joints themselves. So ultimately taking 4 cores from each joint on each side, or for 8 cores for each full construction joint. Okay, so what does that mean?